And you can see on the top 3 antibodies, you see that the vendors have in fact demonstrated that this antibody indeed works, and they are staining astrocytes in brain tissue. Whereas on the left lower corner, we see another vendor who has attempted to validate this antibody in immunohistochemistry, all right, but not on brain, but on lung tissue. And the other 2 remaining vendors couldn't be bothered showing anything but a Western blot. Now, there's one thing that I haven't mentioned yet about this, is that these 6 different antibodies from 6 different brands, in fact, all represent exactly the same antibody. They're all coming from the same manufacturer, from the same catalog number. And so you see here an example that one antibody can occur in multiple catalogs under different brands. And I want to follow up on that in the next slide. When you are shopping around, I advise to go to BioCompare, because basically all commercial antibodies are listed there. And that is what I did for these particular 5 antibody targets. And so when you ask BioCompare how many antibodies there are for ABI1, we get 348 returns spread over 31 different vendors, brands. For example, FOXP3, we get a return of over 1,000 different items on the list. Now, there aren't that many antibodies around, are there? When you have a closer look, and you look at the product sheets, and you look at the QC data and the specifics of how the antibody has been generated, what antigen has been used, etc., you will find that in all these cases, there aren't much more than about 30 different antibodies on the market, except for Nanoc, which has a bit more than 30. So what's going on here? Well, I've looked at PIK3CA, another biomarker famous for cancer research, and I asked BioCompare for the different vendors who possess that particular antibody, and I find that Acris returns 16 different products on their catalog, American Online 10, Lifespan 10. None of them possess any antibody that they manufactured themselves. It's all coming from elsewhere. The first one then, after that, is Abcam, with 9 different products on its catalog, but only 2 of them have been manufactured by themselves. One occurs in 7 different catalogues, and the other occurs in 4 different catalogues. And the other 7 antibodies were not manufactured by them, but are coming from other suppliers. And the same is true for Abnova, with 2 out of the 6 manufactured by themselves. One of them is unique, which means it's not spread across other catalogs, and the other occurs in 5 different catalogs. Now, if you go down further in the list, we also see brands where there are unique products, like Cell Signaling Technology has 2 products that are not shared by anything else. So they're unique, but there's also one that occurs on a different catalog as well. And Origine and Santa Cruz are 2 examples where all the returns were manufactured by themselves and are unique, which means that if you are an assay developer or you're an academic shopping around, It would be good to have a look at those larger vendors, to have a wide possible choice, but you should not forget that there are high quality antibodies out there that are not spread across, and they are unique for its own brand, like these here. And it might very well be that the antibody you are looking for is one of those. And going back to AIF1, knowing that Acris offers the widest possible choice of different products, I've looked at Acris for the ABI1 antibodies. Find 10 different products on its catalog. The 3 goat antibodies are all coming from the same manufacturer. But look, it occurs 4 to 5 times on its catalog. Now, the rabbit antibodies occur only 1 on Acris catalog. But there's another interesting one here. It's a mouse monoclonal antibody, which doesn't have a manufacturer, which means that I think it's been generated by an academic group in university that has subsequently outlicensed it to a vendor. And it has outlicensed it to Acris, possibly, but it occurs for a second time on its catalog, so it has been outlicensed to another vendor as well. And Acris then obtained the catalog items from that vendor that probably also included some of these goats antibodies and brought them into their own catalog, thus generating a second entry of that same antibody, but under a different catalog number. So what we are getting here is that vendors are not only obtaining antibodies from manufacturers, they are also obtaining antibodies from other vendors. And that is how a goat antibody like this one can occur 5 times on its catalog, when Acris is obtaining 1 from the manufacturer, 1 from a vendor who has that same product on its catalog already. Then there could be another vendor who has obtained the product straight from the manufacturer, but also obtained it from a 4th vendor. So they have it twice on its catalog already, and that catalog then is transferred to Acris, and you have doubled the amount of occurrences of that particular product on the catalog. So that's how you end up with 4 or 5 different entries for exactly the same antibody. So welcome to the world of OEM, other external manufacturer. This is what we are talking about here. There's nothing wrong with it. It's good, in fact, because it generates more markets for particular antibodies. And the principle is clear. There is a manufacturer who supplies to an X number of vendors. They take off the label, put their own label on, rebrand it as their own. They sell it as their own. But then they also sell it on to other vendors who take off their vendor's label and put their own label on. And that is how it can happen, that a particular product goes around the world 2 times or 3 times before it ends up at your bench top. Another aspect of OEM is that the owner who has bought that product for its own catalog then is responsible for how it is going to market it. It is not compulsory to use the original QC data. They can do whatever they want because they bought it. So what they will do then is to generate new QC data from their own QC department and apply it for that particular product, or they obtain data from their own customers and apply it. Anything that makes the product look different from the original. And another not so good aspect of it is that, particularly with polyclonal antibodies, is of course the batch-to-batch variations. When an antibody runs out and you have to replenish the stock by immunizing a new animal, new individual, it would mean that the antibody would be slightly different. Could mean that the QC data will look the same but at a different dilution. Could also be that the QC data looks slightly different altogether. So there is that batch-to-batch variation that has been touched by the speakers this morning already. But it means that every single batch that is being released by the manufacturer has to be QC'd as if it was a complete new antibody. And those QC data then are associated with that new batch. But the OEM vendors don't like that, because it is a well-selling product, and it is well-selling because there was this original data that came with it. So they want to keep that data. And they don't necessarily care that the next batch around might not be able to reproduce the original data from the previous batch. And that is when people get frustrated, when they buy a product and they see that the product is fit because it is claimed on the product sheet that it works that way, and then they try it in the lab and it doesn't work. As a customer, you need to be aware that when you buy a set of products for a new platform in order to test which one works best, you have to be aware that some of them might be identical, coming from the same manufacturer. So you need to check the details on the data sheet to see how it was generated, what antigen has been used, in what formulation it came, etc., to make sure that it is different from the others that you bought. Now, another aspect that I want to touch is the way you are going to use the antibody in the lab, and what sort of practical problems you may incur when you do. Now, one thing that we all know is that monoclonal antibodies are, of course, the best. We all know that because it is monospecific. It is just an antibody that binds to one specific region on the antigen, and since it is a monoclonal antibody, you can always get exactly the same molecule back every time again. That's the dogma, right? So when you find that antibody on the catalog somewhere and you find it to work very well in your system, then you're done. You're set. But if there is no monoclonal antibody that works in your system, then you will have to consider the world of the polyclonal antibodies. And there is a lot of ambiguity amongst the polyclonal antibodies. It's not true to think that a polyclonal antibody is just one entity. It's not. And that is depicted here on the left-hand side. Of course, we all know the polyclonal antibodies raised against the entire protein, and we all know that that will give rise to a whole mixture of antibodies with all different affinities and all different specificities. And for each epitope the antibody binds to, there is a chance that there is another epitope out there present in another protein that resembles that epitope, and then that particular antibody will cross-react with that other antigen. So the higher the variety of specificities in such a polyclonal antibody, the higher the chance that some of them will cross-react with something else. So if that is a problem, then obviously you do not want this type of polyclonal antibody. And then the second best thing is to make use of a peptide that is not much longer than 10 to 15 amino acids, because that will approach the size of an epitope and will be specific enough to be unique. And you can decide that up front, because you can blast the sequence into the database to see if there's any overlap with any other known protein in the genome. And if it's not, then you know it's unique. If you use that as an antigen, then you know up front that this antibody is going to be monospecific, just like a monoclonal antibody. Except in this case, you know the epitope up front. And with monoclonal antibodies, you do not always know up front which the epitope is. So you wouldn't necessarily know whether the epitope, when it is unknown, will be similar to other epitopes from related proteins. Now, here are a few examples of how peptide antibodies work. So I forget about all the other polyclonal antibodies. I just focus on peptide antibodies, polyclonal antibodies, and see how useful or how useless they can be. And the first example is a commercial antibody against a peptide that has not been disclosed. My problem with that is that you don't know what you buy. If you don't know the antigen, you don't know what it is binding to. And typically we see two different bands in the Western blot. And upon further dilution, these two bands get fainter, but none of the two are disappearing. So there are lots of issues there. There's another example here for which the immunizing peptide is disclosed. So you can double check how well it is. And it's been tested on a set of different cell lines. And what is so important about this piece of data is that it demonstrates nicely how it is fit for an X number of cell lines, but not to all. There are also cell types or cell lines where the antibody is not fit to. But do you see a lack of bands there? No, there are bands there as well, but much fainter. And not necessarily at the same molecular weight. These are non-specific signals. And you can only distinguish the non-specific signals once they are compared in the same blot with the specific signals in those cell lines that are fit to be looked at with this particular antibody. And what I want to bring across here is that when you were to lower the antibody concentration probing this blot, then these background bands will disappear. But when you increase the concentration of this antibody, then these bands will increase in signal. And if you had a Western blot done on only these cell lines, and you didn't have these positive controls next to them, you might come back to the vendor and say, look, I've tried this antibody, I've used these cell lines, and I got all sorts of non-specific bands. Your antibody is not good. Give me my money back. No, you've chosen the wrong cell lysates, the wrong cell types. You have to include a positive control. For example, the control that was given on the product sheet of that particular product. Finally, some raw data from our own QC department where an antibody is tested on 3 different cell lysates, U937, spleen and PBL, at 2 different concentrations. And in each, so it's the same antibody, but in each different cell type you see different types of background when the antibody was at a too high concentration. When you dilute the antibody further down with a factor 3 or a factor 5, then all these background issues disappear and you get a nice clean band. And that has given rise to these 2 blots for the product sheets. So dilution is a very important feature. In addition, non-specificity could also come from something else, not necessarily from the primary. In this particular case, when an antibody is diluted further down with a factor 3, we see that the intensity of this band is not changing at all. That means that our band is not derived from the primary, it is derived from the secondary antibody. And you then have to either change the secondary antibody or change the blocking conditions. Or in this case, a very simple measure was to take a smaller exposure time so that this band doesn't occur anymore. But it demonstrates that specificity of a primary antibody can be affected by secondary effects. For example, the secondary antibody that was used was not well enough, not clean enough. And another example, final one, is that not all peptide antibodies are fit for purpose. Obviously, some of them simply don't work. I just take this one where an antibody was tested on 3 different brain tissues, brain regions, because it's a brain product. And you get all sorts of different patterns in each brain region, but not the band that we expected. So not all peptide antibodies will work. Here is an example where at least this product does not work in Western blot and therefore it cannot be released to the market. Having said that, not all antibodies that are unfit for Western blots are unfit for anything. We had an example where we released a product with aberrant Western blot bands, and we weren't quite sure what it meant, but because at the time there was no competition for anything better on the market, we released it anyway. And there was a Canadian scientist who came back to me and said, look, I got exactly the same bands, but my antibody was raised in a different species and it was from a different part of the protein. And yet it got exactly the same result. That was encouraging. So we then moved on and we tested this antibody in immunohistochemistry, and we got nice islet of Langerhans staining in the spleen. So the product worked and it did exactly what it was supposed to do. But later on, the scientist in Canada then tested ours and his own in a rat insulinoma cell line. And both of these antibodies reacted with a 70 to 75 kilodalton band, completely different molecular weight than we expected, but it was the right protein. And we only knew that because there were now different antibodies showing the same band, and it was demonstrated that it could be knocked down, etc. So it was right. So in time, when science progresses, it could happen that Western blot failed products then get validated much later in time. And more importantly, an antibody that was proven unfit for Western blot initially might be still proven in other platforms. Some evidence from our own catalog where we have over 40% of our immunohistochemistry antibodies that are unfit for Western blot, but slightly less than 60% of the immunohistochemistry antibodies are fit for Western blot. So one does not exclude the other. Some antibodies work in Western blot and they work in immunohistochemistry, but others work in one application and not in the other. And that principle counts for any platform. If you need an antibody validated in the platform that you are interested in, you do not necessarily want to test it in other types of immunoassays, because each assay is so fundamentally different from the next that comparison is quite pointless. So finally, I would like to discuss a few aspects on quality, how you can address the quality based on what is out there on the market by independent quality checks. Everest Biotech, for example, provides free samples to customers who commit themselves to return the validating data, their own validated data for our product sheet. So we have products, increasing amount of products out there validated by independent scientists, and we say so. We say acknowledgement, data obtained from Professor blah de blah. And Abcam is doing something similar, except they don't give samples away, but they give a discount. More importantly, antibodies online, and I learn now also St. John's laboratory as well, are providing quality stamps in collaboration with Science Exchange Program, which means that there are groups in the United States, academics, who are offering their services to robustly validate an antibody in a standard format. And Antibody Resource is doing something similar, but then in groups from Cambridge and Oxford. And finally, one thing that hasn't been mentioned this morning is One World Lab is offering samples at trial size. So you don't have to spend this amount of money if you only want a quick trial to see if it works or not. And if it does work, then you'll find you can buy a full-size sample or more. But you can start with a 1/10 size sample for $50. And One World Lab then allows you to give feedback and tell the website what your conclusions were albeit positive or negatively, but then the entire world is there to see what your conclusions were. And then there is PapMaps, and Simon will talk later this afternoon about that. It's a platform where any product that you buy from anywhere, you can leave your feedback to them to show what you have found, and if it is a good antibody, it will be listed as good. So that is a good consultation platform as well. And finally, there are the scientific citations, search engines. Andy will talk after me, I think, from CiteApp about that. There's also Antibodypedia and BioBray are other platforms where you can check whether antibodies have been successfully used for publication purposes in the past. That doesn't mean, though, that the current product on the market will still perform accordingly to those papers. If these papers are 5 years old, then it's most likely that the product has moved on, and it might not be exactly the same anymore. So beware of that. So how to shop around? Well, basically, if you are an academic in the lab, you don't need that many antibodies or that this much, and you might as well go to a larger vendor and get a wide range of possibilities to pick from. But when you are an assay developer in an industrial environment, then it is much more important that you get a product that will last for a long time. And like we already mentioned before, if that is going to be a monoclonal, then that worry is less so important. But if it is a polyclonal antibody, you want to make sure that you don't run out of product halfway down the project. Then you buy more, and then it's no longer the same antibody anymore because the bunny died, and in the meanwhile the product has been replaced from a product from a different rabbit, for example. You can't have that. So then you have to go to the manufacturer and make sure that if you have positively tested the product, that there is sufficient amount of stock available that you then can buy altogether to have sufficient amount to last an entire project. That is the best advice that I can give from that point of view. Like I mentioned before, the antigens need to be defined. You don't know what you buy if you don't know where the antibody binds to. Particularly for assay developers, this could be an important thing. And another thing is, I've seen during my search on the internet that certain products were offered by one vendor in as an antiserum, for example, a rabbit antiserum, and then the next vendor had exactly the same antibody, but it was affinity purified. So, but the price were the same, but obviously you don't get the same amount of product for the same price. So you need to be aware of that. What is the formulation, and you want to test it in the platform that you need the antibody for. Please don't test in Western blot if you need it for immunohistochemistry. It makes no sense, really. And for monoclonal antibodies, the clone number can change over time, especially when it was a clone number from 30 years ago. It's unlikely that that same clone number still exists. Just like with cell lines, after so many passage numbers, it won't be the same anymore. Yet there will be vendors out there who will still use that same clone number from 30 years ago. It could very well be that the antibody will not do the same thing as the paper described 30 years ago. So that is a chance that you have to take, but it's good to verify that. And it can also happen that clone numbers change because the vendor had to subclone the hybridoma in order to keep it alive and to keep it stable. And then the number changes. And then you're looking in the literature, I mean, you don't find that clone number anymore because it is now a subclone from it. So these are a few aspects you want to look into as well. And finally, always verify the data that are presented both in the literature and on the product sheet. Always make sure that you have that same experiment in your assay as a positive control. If it doesn't work in your lab, then you have a good argument to say that the antibody didn't work. But if you do your experiment without that positive control, then the vendor will say you haven't done your experiment correctly because you haven't put in the positive control. And with that, I'll leave you, and I'm ready for questions.